There's this one incredible trick behind the electricity that powers pretty much everything in your life. It's an idea that's over a century old, but it's been given a modern twist that is quietly, but fundamentally making our world a whole lot more efficient. I mean, have you ever driven past one of those giant power plants with the huge cooling towers and sprawling buildings and just wondered, what is actually going on in there? What's the secret that turns fuel into the electricity that runs our lives? Well, you might be surprised to learn that at its very core, the idea is almost shockingly simple. Seriously, that's it. For most of the power generated on this planet, that's the basic recipe. You heat up water till it turns into high-pressure steam, and then you use that steam to blast a giant fan, called a turbine, making it spin like crazy. That spinning motion is what generates electricity. Simple, right? But that simplicity is hiding a massive, almost unbelievable problem. To really understand the problem, we first have to appreciate the idea itself. I mean, this whole power of steam thing isn't new. It's been the absolute workhorse of global energy for nearly 150 years. It's even got a fancy name, the Rankine cycle. It's the classic, textbook example of a heat engine. You burn fuel, you create a ton of heat. That heat makes steam, and the force of that steam creates the motion that makes electricity. It's elegant, and it definitely works. But it is absolutely not the whole story. So what if I told you that for decades, this seemingly straightforward process has been part of one of the biggest, most wasteful activities in modern history? A flaw so big, it's almost as if it was designed to just throw energy away. This brings us to what I like to call the great energy heist. And we're not talking about criminals here. We're talking about a colossal amount of energy that just vanishes into thin air every single day. Now, this is the part that is just wild, the sheer scale of the waste. In a typical, older natural gas plant, for every 100 units of fuel energy you put in, you only get about 33 units of electricity out. So where does the other 67% go? Poof! It's just lost, radiated away as waste heat. To really put that into perspective, imagine going to the gas station. You pay for a full tank of gas, but before you can even drive away, 2/3 of it just evaporates right out of the tank. That is the reality of traditional power generation. It is a staggering level of inefficiency. Now, to really get a handle on this, scientists use a concept called exergy. Don't worry, it's not as complex as it sounds. Think of it as the true potential of a fuel to do useful work. We know nothing can ever be 100% efficient, but exergy tells us the absolute maximum we could achieve. And by that measure, these older plants were just incredibly wasteful. So you can imagine this drove engineers absolutely crazy. All that escaping heat wasn't just wasted energy, it was wasted money and wasted fuel. The big question became, how do we stop this heist? How do we catch that heat and put it back to work? And the answer, well, that's where things get really clever. The solution they came up with is so effective, it's basically like getting 2 power plants for the price of 1. It's called a combined cycle power plant, and it completely changed the game. Okay, so here's how this magic trick works. It's a 3-step dance. First, you burn natural gas to spin a gas turbine. Think of a jet engine bolted to the floor. This makes electricity, but it also creates incredibly hot exhaust gases. That's our waste heat. But instead of just letting it escape, that brings us to step 2. A special device called a heat recovery steam generator captures it. And for the grand finale, step 3, all that captured heat is used to boil water and power a second, totally separate steam turbine, which generates even more electricity. And this is where you really see the night and day difference. A simple cycle plant gets 1 shot of power and vents the rest, giving you about 33% efficiency. But a combined cycle plant uses that waste heat to get a whole second round of power, pushing its total efficiency up to nearly 60%. That is almost double the electricity from the exact same amount of fuel. And that is the ingenious trick. It's the ultimate form of energy recycling. That second power boost is essentially free, created from energy that otherwise would have been completely lost. So, this all sounds fantastic in theory, right? But does it actually work in practice? Well, let's take a look at a real-world example that gives us a perfect side-by-side comparison. Let's go to the Ashokganj power station in Bangladesh. It's one of the nation's biggest energy producers. And what makes it so perfect for our story is that they run both the old traditional steam units right alongside modern, brand new combined cycle units. It gives us a direct, real-world test. And the data? It's crystal clear. Looking at the plant's performance averages from 2016 to 2021, the old steam units were hovering right around 33% efficiency. The new combined cycle units, they averaged a whopping 57% efficiency. That is a massive leap in performance. So what that really means is Ashwagandha can now generate way more power without burning a single extra bit of fuel. They're just squeezing more work out of the energy they already have, which is a huge win for the economy and for the environment. So, what does this all mean for our energy future? Well, it's about a fundamental shift in how we think about energy. You see, the story of the combined cycle power plant isn't just about some clever engineering. It's a masterclass in efficiency and sustainability. It proves that one of the most powerful sources of new energy is the energy we're currently wasting. The goal isn't just to produce more, it's to waste less. And that leaves us with a final, really important question. This two-for-one mindset is an incredibly powerful tool. So as we look for ways to power our growing world, where else can we find these hidden opportunities to capture what we call waste and turn it into work? If you found this explanation useful, hitting that like and subscribe button really does help us create more of them. Thanks for watching.